Good morning, students. So in previous lecture, we studied regarding basic operational concept of computer. We studied how MAR, MDR, program counter, and instruction register together will execute a complete instruction. Fine. So in today's class, we are going to discuss about bus structure. Fine. So bus is a cable which we are using to connect all the functional units so that they can communicate with each other properly and achieve the task faster. Fine. So here we got a structure. We are calling it as a bus structure. And one more name for this structure is single bus structure. Fine. You can observe this is what the bus cable. This is what the bus cable. For that, we are connecting our all the functional units. Don't get confused. In previous class, we discussed about 5 different functional units, but here we got only 4. Okay, so arithmetic logical unit and control. Okay, together we are specifying it as processor. Fine. So each and every functional units must be connected to bus cable. Okay, so that we can enable the communication between all the functional units. Fine. You may ask why we have different direction for these arrow marks. Fine. Input towards the bus cable, for output away from the bus cable. Bidirectional we have for memory and the processor. Fine. When it comes for input, fine, user need to provide an input for a computer. Yeah, because of that, we are having a unidirection towards the bus cable from the input unit. Whatever we are providing the input, that will be from user to the system. Okay, so it should be towards the bus cable. Fine. Then when it comes for output, okay, just observe when it comes for output, we are having away from the bus cable. Why it is so? Because whatever the data we want to display, okay, that will be displayed through output exactly or output units. Fine. If I want to display the output, then we need to upload the content, whether it may be from a memory, whether it may be from a processor, or it may be sometime from the input, okay, to the output unit so that the output unit can display the content for the user. Yeah. So we are having the unidirection towards the output unit, or also we can call it away from the bus cable. I hope you understood why we are having unidirectional for input and output. Next, when it comes for memory, there are 2 main operations we need to perform. What are those? One is reading the content from the memory, and second is writing a content to the memory. Fine. Sometimes we need to fetch the memory content to the processor, fine, from the memory to the processor. Because of that, this direction is mentioned. And sometimes after the computation, okay, a result must be stored in the memory. Because of that, we are having this direction. Okay, so bidirectional we must have for memory. Clear? Okay. Then what about for the processor? Obvious, we must have bidirectional communication for the processor. Why? Because we need to bring the content inside the processor for the processing. Later, after the generation of result, either it should be displayed through the output unit or it should be stored in a memory. Because of that, we are having bidirectional communication for processor. I hope you understood why these arrow marks are different. Fine. Okay. Now, when it comes for bus structure, very important thing is this bus cable. Okay. Single bus structure we are calling it as. Okay. This is the representation of the single bus cable. Why? Because the number of bus cable we are using to connect our functional units are how many? Only 1. Because of this, we are calling it as single bus structure. In module number 5, we need to discuss multiple bus structure. There we are using 2, 3, 4, such kind of bus cables are increased for. Okay, for better performance. Okay, we need to discuss a drawback of the single bus structure in this session. Okay, so to overcome that drawback, what we need to do? We need to go for adding multiple number of bus cable so that communication can be done faster. Clear? Okay, so here we got a representation of a bus cable. Okay, this is one cable, fine. Internally, it will be having a three section. This is very important. Okay, this is a bus cable, the same representation, but internally it consists of three different lines. The first line, we call it as address line. Second line, we call it as control line. And third one, we call it as data line. Fine. So the inside the address line, whatever the targeted functional unit or targeted device we have, okay, which we want to communicate, that address will be uploaded. I repeat, okay, inside the address line, the targeted device address will be uploaded. Okay, then later, what kind of communication you want to establish, whether it is a read kind or whether it is a write kind. Okay, regarding that, control signal will be uploaded in the control line. Control signal should be uploaded in control line. Fine. Then, what is the use of this data line? Okay, so whatever the data we want to upload for a bus, okay, or else sometimes the data what I want to communicate or processor want to communicate with any other functional units, the data will be uploaded in this particular data line. Yeah, I hope you don't have any doubt regarding these three lines. Address line, the device address will be uploaded. I will discuss how to assign an address for a devices, what kind of addresses will be assigned and all for the topics and all. Okay, so each and every devices will be having their own unique identification address. Remember this. Okay, each and every devices which are all connected to your motherboard, okay, through wired or wireless. Okay, so each and every devices will be having their own unique identification address. Based on that, we will establish a communication. Fine. So the respective address of a targeted device will be uploaded in the address line. Then what kind of operation I want to perform, whether it is a read or write operation, that will be uploaded in a control line. Then the data, if I want to transfer it for the targeted device, okay, then data will be uploaded in the data line. Yeah. So this is what the three tasks which will be achieved by the bus cable. Yeah. Okay. Now we come to the address line. What exactly this address line stands for? Remember, whenever we are connecting our input unit, output unit, okay, through wire it may be or through wireless it may be, okay, whenever a system detects any device, okay, then it used to assign a unique identification address for that particular device over there. Fine. So this will be defined locally. Yeah, this will be defined locally. Okay, so your processor or each and every device will be having the information regarding the addresses of the targeted device. Remember this. Okay, fine. So based on this address itself, we will establish the communication. Okay, from address to address. It's must. Right. Okay, from where we are going to get the information to where we are going to transfer, these two information are must exactly. Right. Okay. For this purpose, the address line will be utilized. Okay. Now, let me take an example. Like I want to type some information using a keyboard. Okay. And it should be displayed. Example like MS Office. Okay. We have a software of MS Office software we have. Okay. Then using MS Office, I want to type some letter for my friend. Okay. So what I do, I will go for desktop option. Okay, if there is a shortcut, okay, fine. Otherwise, right click, select MS Office. Okay, open it, rename it, what name you want, fine, open it. Then later, we will start typing, right? From where we are typing using keyboard. That is what the input unit. Okay, and what is the target? What is the target? Target is what? The output unit over there. Simultaneously, whenever we are writing, okay, simultaneously we are going to get a gesture of those alphabets in our monitor, right? So this is what the communication between your input unit and the output unit over there. Fine. The data will flow like this. From input unit, it will come to bus cable to output unit. Now, this is what the general kind of communication, okay, between your input and output, okay. So we are not only involving input unit and output unit, we need to involve memory and also the processor. Processor is must and should. Okay, remember, processor is must and should, fine. But while using the MS Office, the draft or as the page, whatever we are using, that will be in a temporary storage location. Okay, when we go for the save option, then only memory will be encountered, fine. Till that, we are utilizing the temporary storage. Okay. Now, for time being, okay, that will be a bit advanced kind of topic. In further classes, we will discuss about this. Okay. For time being, you consider like we are typing using a keyboard and using a MS Office, we are displaying that. Okay. Then the communication will be between input to bus to output over here. Fine. Whenever we are typing, okay, what is the target address we need to upload over here? Okay, the target address is address of output. Consider the input unit is having an address called as 1, output unit is having an address called as 2, memory is having 3, and your processor is having 4. Fine. Okay. Now, if input unit, which is having the address of 1, want to communicate with the output unit, which is having the address of 2, then what it must do? It should upload the target address as 2 over here. Fine. Remember, using this bus cable, each and every functional units are connected for all these 3 lines over here. Address line, control line, and data line. Fine. All the functional units are connected to all the 3 lines of the bus cable. So, whenever the address is specified in the address line, okay, they used to participate in the computation of address decoding. Fine. Once they get a match, see, output unit is also participating in a address match. Okay, memory is also finding the address. Okay, processor is also checking for the address. Okay, but actually, after the decoding of the address, for whom we have a match, we have a match for the output unit because we have 2 over here. Here also we have a 2. Fine. Then later the output unit will go through the control line. What should be the control statement we need to provide over here? See, input is providing the input for the output. Then what kind of operation should be performed under output? We need to write the content for the output. Is it right? We need to write the content for, we need to upload the content for the output unit. Because of that, write will be the command which will be generated by this particular bus line. Fine. Then later, what I want to do is the input content. Okay, example like my name is Prasad. I'm typing like my name is Prasad SR. Okay, so this is what the data I want to write in my MS Office or else from Professor Prasad. So this is one like I want to type in MS Office. Okay, and I will start keep on typing, right? Okay, then those information like my name is Prasad. Okay, everything will be uploaded in this data line. How it will be uploaded, on what format it will be uploaded. That is the advanced kind of topic we'll discuss later. For time being, we can consider like, okay, the data, whatever we are typing using the keyboard, that will be uploaded in the data. Fine. Okay. Now we have a match of address, we have a control what we need to do, and we have a data. That's it. Okay. So write is the command. So output will start writing what content, the content which is available in this data line. I hope you understood. Okay. So the final conclusion of this basic structure or else bus structure is, if one device want to communicate with another device, it should specify the address of the target device. Okay, along with that, it should specify what kind of operation it would like to perform, either read operation or write operation. And in case of write operation, we need to provide the information like what should be written inside the target device. Okay, in case of read information, after the completion of read operation, the targeted device will upload the content for the data line. Reverse process it is. Okay, while writing, we need to provide the information. Okay, what should be written? The content should be available in the data line. But after the read operation, okay, like the result of read operation, whatever the content we are reading, right, that should be uploaded for the data line, and that data will be utilized by the initiated device. Okay, initiated device. Remember, the device which has initiated the communication, right, that will be transferred for that initiated device when we are mentioning a control line signal called as a read over. Here, then I was discussing, like I specified some sort of limitation we have over here. What is that limitation? Okay, fine. Let me clear the screen. So here we got total 5 different functional units. Okay, so which is having ability to communicate with each other using the bus cable. Okay. Now the condition or the question arises: how many devices can communicate at a time? Simultaneously, how many different functional units can communicate with each other? Okay, the answer is only 2 devices. Remember, this is what the drawback of single bus structure, or else the bus structure which is mentioned in your module number 1, okay, is having a drawback of what? At a time, only two devices can be active. One will be the initiator and second will be the target. Okay, one initiator and one target, okay, can be active at a time. Okay, now the problem is what? Okay, see, according to my explanation, okay, device 1 want to communicate with device 2 right now. Okay, the time is around like 11 o'clock. Okay, so 11 o'clock, sharp 11 o'clock, input unit is communicating with the output unit. Okay, done. Okay, we will allot the resources. Okay, the communication is performed. Okay, meanwhile, at sharp 11 o'clock itself, a device which is having an address of 3 and which is having a 4, if these two want to communicate with each other, then what should be done? Getting or what? See here, we got total 4, 5 functional units available over here. Okay, input unit want to communicate with output unit. Okay, at a time of 11 a.m. Yes, it's established the communication. Now, input unit is communicating with the output unit, but meanwhile, memory, which is having an address of 3 and which is having an address of 4 processor, they want to establish a communication, but the bus structure will not let this communication to happen. Second one, why? Because only only two devices can be active at a time. This is what the condition. Now, if this is the case, then what should be done? Okay, should they wait? Okay, these two devices, should they wait till the communication between 1 and 2 get over? If you say yes, fine, then it will drop the performance of your system. Fine. We need to achieve the multitasking, right? Then only we can go for experiencing the better performance of your system. Okay. So what we need to do, if this is the case, say 11 o'clock is the time, input and output is communicating, meanwhile memory and processor want to communicate. If the system or if the user made these two to wait, okay, then the performance of your memory will be less, right? The performance of your processor is also become less old. It will decrease. So what we need to do is, okay, we need to go for an alternate solution. What is that alternate solution? Okay, so we need to avoid this waiting loop. Okay, if two devices are busy, okay, we should not make other two devices to wait for the completion of the process. So what we can do over here? Okay, any idea? So the solution is we are providing a temporary location called as the buffer register for each and every functional units available over here. Okay, each and every functional. See, I am mentioning it as functional units. That is nothing but appropriate devices. Input, what all devices will come for them. Output, what all devices will come for them. Okay, so for each and every functional unit, we are specifying or we are providing the buffer registers over here. Okay, so here we are mentioning here buffer register. So this is what the temporary location. Fine. Now, according to my example, 1 is busy with 2. Okay, and here 3 is also willing to communicate with processor example. Now, we should not make these two devices for wait. Okay, so what we need to do? We need to go for continuously uploading the content what memory want to communicate with the processor should be uploaded in the buffer register. I repeat, the content what memory want to communicate with the processor should be uploaded for the buffer register. Fine. Once, okay, fine. After uploading, what will be the next procedure? Okay, now 1 and 2 is utilizing the bus cable. Okay, fine. 3 and 4 want to communicate. Okay, so what we have option, we can upload it for the buffer register. Yes, memory will upload the content for the buffer register. Fine. And it will suspend this operation. Remember this. It will suspend this operation and memory will be concentrating on other task. Okay, instead of wasting the time for waiting the bus get free, okay, it will just upload the content what it want to communicate to the buffer register and it will start what? It will start for concentrating on another operation over here. Okay, then we are not making memory to wait over here. We are not making processor to wait over here. Once the communication between input and output over, okay, then the bus will be free. Then the content inside the buffer register will be uploaded for the bus cable. Okay, and finally, the communication will be established between the processor. Okay, so this is what the simple arrangement what we can do to overcome only two devices can be active at a time problem which we are facing in single bus structure. Okay, one best example is example of printer buffer loading. Okay, so whenever, like if you are having a PDF file, okay, you can try this. If you are having a PDF file of around like 60 pages, okay, connect your printer, okay, and work for a print option. Okay, just print all the pages. Okay, try to print all the pages. Just do it. Okay, no need to take a like 60 copies of printer print out. Okay, just try it. Okay, without paper. Okay, you will get a dialog box. Okay, in that you will see something is getting uploaded over there. Okay, that inside the dialog box, that green line will continuously moving towards the end. Okay, so that is indicating like we are uploading the content. Okay, it may be residing in your pen drive, right? The PDF file may be residing in your pen drive. It may be residing in your desktop or any disk option. Okay, or as a disk file, it may be any folder. It may be. From there, we need to start uploading the content for the buffer register of a printer. Remember this buffer register of a printer over there. Okay, it should be uploaded over there. Fine. And one more example we can consider like if your printer is already printing some paper, okay, consider, okay, 10 pages you are already printing. Meanwhile, 10 more paper you want to print again. Okay, so meanwhile, if you are giving a print option, again it will show like buffer loading over there. Okay, see, already that content is printing over there. Okay, and again you are uploading the content for the buffer. Then after the completion of the 10 paper, okay, the second half, the second 10 paper, whatever we uploaded second time, that will get printed over there. Okay, so this is what the application or the benefit of using buffer registers for the devices. Each and every port, whatever we are using, USB ports and all, okay, everywhere we'll be having a buffer register. Okay, for what purpose? To overcome these kind of issues or overcome the waiting loop of the devices. Yeah, okay. So this is all now. Thank you, students.